So if I drag this class textbook across the desk, it seems hard to move. It doesn't slide really easy. And of course, you're going to tell me that's because it has friction. So what if I change the surface? What if I took this and slid it across? Would that be any different? Hard to say. So what we're going to do in today's class is we are going to calculate friction. So we have a couple different types of forces, and we need to understand the difference between contact and non-contact forces. So for instance, hopefully you've played with a magnet before, and you've seen that magnets can pull things without actually touching them. That is a non-contact force, and gravity is another non-contact force. Friction, on the other hand, is a contact force. And the amount of friction that something has is related to what's going on with the surfaces between the two objects. With friction, we need to realize that there's two different states the object can be. The object can be either stationary or not moving, or it can be in motion. And what we have realized is that the friction is different between the two states. When the object is not moving and we're trying to get it started, that is referred to as static friction. When the object is in motion and we have friction that opposes the motion, that is referred to as kinetic friction. And please note that static friction is always greater than kinetic friction. So when objects have motion, there is friction in place. So for instance, in this cart, there would be friction between the little wheels and the surface. But there would also be friction inside the little axle here where it's rubbing against the cart itself. When you look at, say, the bottom of the calculator, they've put little pieces of rubber on the bottom of the calculator so that it does not slip off your desk easily. But normally what we're looking at is we're looking at two smooth surfaces, and those two surfaces interact with each other. And really what it comes down to is it comes down to the force of attraction within the molecules. The positive neutrons in the nucleus of the table, and the electrons in the cloud of this piece of aluminum have an attraction, van der Waals forces, London dispersion forces, and so on. But there is this force of attraction. And what we need to do is we need to actually pull it hard enough to break those forces of attraction. I've got my drawing here. Let's say I've got a textbook. There's my physics textbook sitting on top of a table. And what is going on? Well, what is happening is that this book is being pulled downward due to the force of gravity. And what has happened is that it has created this contact spot in here amongst the surfaces. And that's where the friction is going to happen. So as I try to move my book along, what's going to happen? So if I move it with some applied force, what's going to happen is that I have some kind of frictional force pulling it in the opposite direction. We also have an additional force, which we're going to talk more about later, but this is what we call a normal force. Okay? And I'm just going to write that down. This is our normal force. And the normal force is an indication of how hard are these two surfaces being pushed together. And the normal force is equal to the force of gravity in this situation, except that one has opposite direction. And because it has opposite directions, what we would normally do is we would say that the one of them is in a positive direction and the other one is in a negative direction. The positive and minus just indicate one's going up and one is going down. Next is what we call the coefficient of friction. Coefficient of friction. And basically what this is a ratio where we are comparing the amount of friction to the normal force. And when you compare those two numbers, you end up with this symbol mu. So mu is the coefficient of friction. There are no units for mu, and that's because if I had an example, let's say we had a normal force of, let's just say, 10 newtons, and we had a force of friction of, let's say, 2 newtons, and we calculated mu, we would find that 2 newtons, oops, almost got carried away with my units here, we'd have 2 newtons divided by 10 newtons, and what we would have is an answer. Mu would be 0.2. That is our coefficient of friction for that surface. So let's say we have a problem. Let's say we know that our frictional force is 18 newtons, and we have a coefficient of friction between the surfaces of 0.31. And we need to find the normal force, the force of gravity, and the mass of the object. So where do we start? Well, I know that the coefficient of friction is the ratio between the force of friction and the normal force. So since we have the force of friction and mu, we know that mu was 0.31, and we had 18 newtons of force there. We can use this, double check my numbers, 18.31. We can do this. We can find that our force of friction is equal to 18 newtons divided by 0.31, our coefficient of friction. And so what we have there, when we use our calculator, is we have an answer of, rounding this off, 58 newtons is our normal force. Okay, now what is our force of gravity? Well, gravity is the same magnitude, but it is in an opposite direction. So this would be up, and this would be down. If you would like, you could say that in terms of a positive or negative number. You could say that the Fn is a positive 58 newtons and our Fg is a negative 58 newtons. I love using the words up, down to describe it. Okay. We know our force of gravity. Well, what is the mass of the object? Well, we know that the weight of the object is the force on gravity, is the mass times acceleration, or we could say that the weight is mass times gravity. And we want to find the mass. I'm going to do the algebra first. So I'm going to say that mass equals the force of gravity divided by the acceleration due to gravity. So what I have here is I have that the mass would be equal to 58 newtons divided by 9.81 meters per second squared. And I want to point out, don't forget, that a newton is simply a kilogram meters per second squared. So when I do my analysis here of my units, it'll all work out. So I'm going to take my, my weight, and I'm going to end up with a mass equal to 5.9 kilograms. It's not a negative mass, it's just simply a mass.